Welcome to Ask and Learn.
So here in this problem we have to determine the gravitational force which titanium sphere exerts on the copper sphere, and the value of R we are given in the question as 40 mm. So 40 mm is the radius of titanium, and for copper it is 80 mm. Now we have to calculate the gravitational force. So for that we'll be calculating the mass of titanium sphere and the mass of copper sphere. So the mass of copper sphere is given by the density of copper times the volume of copper, and the density of copper we have 8,930 kg over meter cube, and volume for copper, that is it's a sphere, so 4 by 3 pi r cube, and in this case for copper r we have 2r, so 2r cube. Now we can put the values 8930 kg per meter cube times 4 by 3 pi. 2 times r is 80 mm, but we have to take the values in meter, so it will be 0.08 cube. So we're going to simplify this and we'll get the mass of copper as nearly 19.15 kg. So this is the mass of copper. Similarly, we'll be calculating the mass of titanium, which is given by the density of titanium times the volume of titanium. So density of titanium we have 4500 kg per meter cube times 4 by 3 pi r cube. Here the radius is r only, that is 40 mm. So 40 mm in meters it becomes 0.04 meter cube. Now we're going to simplify this and we'll get the mass of titanium as 1.206 kg. Now we have calculated the mass. Now we can easily calculate the gravitational force. Now the gravitational force exerted by the titanium on the sphere, copper sphere, is given by F is equals to minus G m of titanium times the mass of copper divided by d square, where d is the distance between the center of sphere of titanium and copper, and g is a universal gas constant. Now we can put the values here to calculate F. So it is equals to minus 6.6726 times 10 to the power minus 11 times mt we have 1.206 and mc we have 19.15 divided by d square. So d is 6r here, so 6 times r is 40 mm, means 0.04 meter. Now we're going to simplify this and we'll get this value as minus 2.675 times 10 to the power minus 8 Newton. Now this is the magnitude of the force. We can also calculate the force in vector component. So it will be equals to magnitude of force times cosine theta I cap plus magnitude of force F times sine theta j cap. And now we can plug the values here. So minus 2.675 times 10 to the power minus 8 cosine theta, and theta we have 35 degree, so 35 degree, and this is in I cap x direction, minus 2.675 times 10 to the power minus 8 sine 35 degree, and this is in j cap, that is in y direction. Now we're going to simplify this and we'll get the vector component of force as minus 2.19 I cap minus 1.534 j cap times 10 to the power minus 8 Newton. So this is the final answer for the given problem. I hope you have understood the problem. Thank you.